Welcome to the 21st lecture of Digital Electronics subject. Okay, so coming into a recap of last lecture. So in the last lecture we have completed with combination law, AND law, OR law, commutative law and associative law, and we have dealt with axioms of Boolean algebra, that is given in lecture number 20. Now in this lecture we will be dealing with distributive law, redundant literal rule. We'll be dealing with distributive law, redundant literal rule, idempotence law, absorption law, and included factor theorem. Absorption law and included factor theorem. These five laws will be dealt in this section. So coming into first one is distributive law. Distributive laws. Okay. The first distributive law, in that we have first one is A and B or C is equal to A and B or A and C. Second law is A or B and C. A or B and C is same as A or B and A or C. These are the two distributive laws. Okay. First one is A and B or C is AB or AC. A and B or A and C. Now second one is A or B and C is same as A or B and A or C. Okay. So this is basically in OR format. This is basically in AND format. Okay. So let us prove all these laws in a single glance. Then it will be easy for you. Okay. So I have three inputs. I will draw the truth table for all the laws in a single stretch. Okay. So first one I am having three inputs. What is it? Inputs are A, B and C. I have three inputs. So 0, 0, 1, 0, 1, 0, 0, 1, 1. One second, I have forgot about the other part. Okay. So let us forget 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 0. What is the 1, 0, 0? Next one is 1, 0, 0, 1, 0, 0, 1, 0, 1, 1, 1, 0. Last one is 1, 1, 1. Okay. So these are the inputs. First you calculate. So first I am going to calculate the left side of this one. What is it? B or C? Okay. B or C. What is B or C? 0 or 0? 0. 0 or 1? 1. 1 or 0? 1. 1 or 1? 1. 0 or 0? 0. 0 or 1? 1. 1 or 0? 1. 1 or 1? 1. Now I will write A and B or C. A and B or C. Okay. So it is 0 and 0. 0. 0 and 1. 0. 0 and 1. 0. 0 and 1. 0. 1 and 0. 0. 1 and 1. 1. 1 and 1. 1. 1 and 1. 1. Okay. That is A and B or C. Now I will write A and B. Then I will write A and C. After that I will write A and B or A and C. What is A and B? 0 or 0? 0 and 0. 0. 0 and 0. 0. 0 and 1. 0. 0 and 1. 0. 1 and 0. 0. 1 and 0. 0. 1 and 1. 1. 1 and 1. 1. That is AB. Now come to AC. 0 and 0. 0. 0 and 1. 0. 0 and 0. 0. 0 and 1. 0. 1 and 0. 0. 1 and 1. 1. 1 and 0. 0. 1 and 1. 1. Now come to AB or AC. That is 0 or 0. 0. 0 0 0 0 0 0 0 0 0 0 0 0 or 1 1 1 or 0 1 1 or 1 1. Now we can see that these two columns are exactly the same, which proves that A and B or C is same as A and B or A and C. Okay, so that is a proof of the first law. Okay, now let me try the second one. What is the second law? Second law is A or B, second law, that is A or B and C. A or B and C is A or B and A or C and A or C. Okay, so A or B, yeah. Okay, so let me prove it. Let me have these columns first. Okay, I'm having inputs as A, B and C. I'm having A, B and C as input. So 0 0 0 0 0 1 0 1 0 0 1 1 1 0 0 1 0 1 1 1 0 1 1 1. Now coming into first one, first law, that is here I need to have the BC. So what is B and C? 0 and 0 0 0 and 1 0 1 and 0 0 1 and 1 1 0 and 0 0 0 and 1 0 1 and 0 0 1 and 1 is 1. Now I need to calculate A or B and C. So this 0 or 0 0 0 or 0 0 0 or 0 0 0 or 1 1 1 or 0 1 1 or 0 1 1 or 0 1 1 or 1 1. That is A or B and C. Now I need to calculate A or B. What is A or B? 0 or 0 0 0 or 0 0 0 or 1 1 0 or 1 1 1 or 0 1 1 or 0 1 1 or 1 1 1 or 1 1. Now A or C. This A or C. 0 or 0 0 0 or 1 1 0 or 0 0 0 or 1 1 1 or 0 1 1 or 1 1 1 or 0 1 1 or 1. That is 1. So last one is A or B and A or C. So you need to add these two. 0 and 0 0 0 and 1 0 1 and 0 0. Okay. Now 1 and 1 1 1 and 1 1 1 and 1 1 1 and 1 1 1 and 1 1. So here we can see that these two columns are exactly the same, which proves the second law. Okay. Now if you are drawing a logic circuit for the first law, first distributive law, that is A and B or C is same as A and B or A and C. That means A and B or C. So we have B, C. So it is ANDed here. So this is B or C. This is A and B or C. B or C. That is the same as A and B. A and B. This is A and B. Then next one is A and C. A and C. A and C. And you should OR it. Okay. So that is the logic circuit for first one. So what is the second law? That is A. Second law is A or BC. A or BC is A or B. A or B and A or C. Okay. So how do you check it? So A or BC. So you have B, C. So you have and you get B and C. Now we get A. Okay. So you will get here you will get A or B and C. That is same as A or B. So you will get A, B, C. A or B. A or B. And A or C. So you get A or C. And you should AND it. That is the result. Okay. Here you will get this is AB or AC. Here you will get A or B and A or C. So let me explain it with a very simple how to explain it with the logic inputs. So here let A is equal to 0, B is equal to 0 and C is equal to 1. That means here also I will get 0, 0, 1. A very simple example I will show you. Here what will you get? B or C. So it is 0 or 1. You will get 1. Then A and B or C. What will you get? 0 and 1. 0 and 1 is 0. Okay. Now here what will you get? A and B. 0 and 0. You will get 0. You will get A and C. 1. Here what will you get? You get 0, 0, 1. What is B or C? 1, A. So it is A and B or C. Right? Yeah, it is A and B or C. That is 0 and 1. 0 and 1 is 0. So you get A, B, C. So, sorry, it is A and C. A and C is 0 and 1. 0 and 1 is 0. Okay. So what will you get? 0 or 0. You will get 0. So you will get the same output. Okay. Now one more example I will show you here. Okay. Let the input A be 0, 1, 0, 1, 0. Okay. 0, 1, 0. Okay. So what is B or C? B or C is again remaining as 1. Then A and B or C, that is 1 and 0. The answer is 0. Okay, so here I am giving the 0, 1 and 0. Okay, what is 0 and 1? 0 and 1 is 0. Now here what will you get? 0 and 0. You get 0. So what is 0 or 0? The answer is 0. Hence we can say that these two circuits exactly functioning is the same. I will show one example here also. Okay, so 0, 0, 1, 1. For example, okay, what is B and C? 1 and 1. That is 1. What is 0 or 1? 0 or 1 is 1. So here also I can give 0, 1 and 1 as input. What is A or B? A or B is 0 or 1. You will get 0. Then here what do you get? A or C? That is 0 or 1. You will get 1. Now, okay, wait. 0, 1, 1. Yeah. A or C, that is 0 or 1. 1. Here we get A or B. So here the value is 1. Sorry. 0 or 1. Answer is 1. So answer is here we get A or B and A or C. It is 1 and 1. So answer is 1. Therefore, what you can see that for the same type of input, you are getting the same output. Okay. This proves the distributive law. Yeah, this is law 1 in distributive law, and this is law 2 in distributive law. That proves the distributive law. Now coming into redundant literal rule. Okay. So second one I am going into redundant literal. That is the seventh one. So that is not first one. This is sixth one. Okay. Now coming into seventh one. I am going into redundant literal rule. Redundant literal rule, it is also known as RLR, redundant literal rule. So here we have two laws. First law, law 1 is A or A bar B is same as A or B. Second law is A and A bar or B is same as A and B. Okay. So these are the two fundamental rules. So first is for OR rule and second one is AND rule. So let us try to prove it. So here we are having only two variables, so we can prove it easily. Okay. So I will have inputs. There are only two inputs. Which are the inputs? A, B. So here I will have A bar, then A bar B. Okay, A bar B. Then I have A or A bar B. Then what I have is A or B. Okay. Then I have A bar or B. A bar or B. Then I have A and A bar or B. Okay. And the last term what I have is A and B. Okay. I'll write everything in a single truth table. That will be easy for you. So you have 0, 0, 0, 1, 1, 0, 1, 1. A bar, what do you get? 1, 1, 0, 0. That is A bar. Okay. Now what is A bar B? 1 dot 0. 1 dot 0 is 0. 1 dot 1 is 1. 0 dot 0 is 0. 0 dot 1 is also 0. Now what is A or A bar B? Let me write it in another color. A or A bar B. So that is 0 or 0. 0 or 0. That is 0. 0 or 1. 1. 1 or 0. 1. 1 or 0. That is 1. Now we write A or B. What is A or B? 0 or 0. 0. 0 or 1. 1. 1 or 0. 1. 1 or 1. That is 1. So you can see that these two columns are exactly the same. Therefore, that proves the first law. That proves the first law. Next one is A bar or B. Okay. Next one is I will write A bar or B. What is A bar or B? 1 or 0. 1. 1 or 1. 1. 0 or 0. 0. 0 or 1. 0 or 1 is 1. Now, next I will write what? A and A bar or B. So it is 0 and 1. 0 and 1 is 0. 0 and 1 is 0. 1 and 0 is 0. 1 and 1 is 1. Now we will get A and B. A and B. A and B. 0 and 0. 0. 0 and 1. 0. 1 and 0. 0. 1 and 1 is 1. So you can see that these two terms, these two columns are same, which proves the second law. That means you can say that A and A bar B is same as AB. Similarly, what you can say, A or A bar B is same as A or B. Okay. So that proves redundant literal rule. So to have a logic circuit of it, A or A bar B. So what is the first law? First law is A or A bar B is same as AB. Second law. Second law is what is second law? Second law is A and A bar or B is same as A or B. Right? Sorry, that is A and first one is A or B. Wait. First one is A or B. First one is A or B. This is A and B. So let me draw the logic circuit of first one. Okay. A or A bar B. Okay. A is there. B is there. Okay. So A or A bar B. A bar B means I will have a NOT gate here. A bar B. So here what do we get? A bar B. Now A or A bar B. So what do I get is A or A bar B. That is the same as A or B. Okay. A or B. That we need to prove. Okay. This we need to prove. So let me have some inputs here. So let my input be 0 and 1. I will show it only 1. So what is A bar? A bar is 1. So So what is A bar B? 1 and 1. 1 and 1 is 1. Now here what do we get? 0 or 1. 0 or 1 is 1. Okay. Now here what I have given, A and B as 0 and 1. So what is 0 or 1? 1. So you can see that for these two inputs here, the output is exactly the same. Therefore we can say that these two circuits are exactly the same circuit. Okay. Now that is of law 1. Law 1. Coming to law 2. Coming to law 2 is A bar. So we are having A, B. So you will get A bar or B. Here we will get A bar or B. We have a OR gate. So this is A bar or B. Okay. A bar or B and A. Okay. You will get A and A bar or B. That is the same as an AND gate. A, B. We get A and B. Let us test it with a very simple logic. Okay. So A I am giving 0, B I am giving 1. Okay. What is A bar? A bar becomes 1. So what is A bar or B? 1 or 1? 1 or 1 is 1. So here what we get? 1 and 0. 1 and 0 is 0. Okay. So here I am having 0 and 1. So what is 0 and 1? Answer is 0. So we can see that for the same inputs, you are getting same outputs. Okay. Therefore we can say that redundant literal rule is valid. Okay. Now coming into ninth law. Ninth law is idempotence law. Idempotence law. That is the ninth law, idempotence law. Okay. There are only two laws. Okay. First one, law 1. A dot A. A dot A is equal to A. Second law, law 2. A or A is also is equal to A. Okay. So let me have a truth table for it. Okay, you are having only one input. So you are having A. Okay, A. I am having two inputs. That will mean like that. Inputs. So A means I should have same A. So 0, 0, 1, 1. Only these two should be the inputs. Okay. Now I will write A dot A. What is A dot A? 0 dot 0, 0. 1 dot 1 is 1. So what we can write? A dot A is same as A itself. Okay. Similarly, this is same as A itself. Similarly, what is A or A? 0 or 0. That is 0. 1 or 1 is 1. So these also is same. Therefore, we can say that A dot A is equal to A as well as A or A is equal to A. That means if you are drawing a logic circuit for first law, you are having A as input. Okay. Here what do we get? A dot A. A dot A is same as A itself. Okay. Now similarly, what will we get? Law 2. Law 2. What is A or A? I should give A as input to both inputs. So what will you get? You will get A or A. That is same as A. For example, if I am giving 0, you will get 0. 0 and 0 is 0. So 0 is equal to 0. That means you will get the value of A itself. Here I am giving 1. 1 or 1. 1 or 1. That is 1. That is the same as value of A itself. That proves the idempotence laws. Now coming into 10th one. 10th one is absorption law. 10th one. That is coming into absorption laws. With this law I am ending with this lecture. Absorption law. Okay. We are having two laws. First law. Law 1 is A or AB. A or A and B is A. Second law. Second law is, what will be the second law? A and A or B is also is equal to A. So to have a proof of it, okay, I have only two inputs, A and B, in truth table form, okay. So I am having two inputs, A and B. So 0, 0, 0, 1, 1, 0 and 1, 1. Okay. Now I write A and B. Here what do we get? 0 and 0, that is 0. 0 and 1, 0. 1 and 0, 0. 1 and 1 is 1. Now A or A and B. A or A and B. What do we get? 0 or 0, 0. 0 or 0, 0. 1 or 0, 1. 1 or 1, that is 1. So here what you can see is that the first column matches with this column. That proves the first law. Okay. Now second one is you need to go for A or B. A or B. Okay. So A or B. A or B. What is A or B? A or B is 0 or 0. 0 or 0 is 0. 0 or 1 is 1. 1 or 0 is 1. 1 or 1 is 1. Okay. Now last step I should go for A and A or B. A and A or B. What is A and A or B? 0 and 0, 0. 0 and 1, 0. 1 and 1, 1. 1 and 1. That is 1. That is also same as the first column. Okay. This proves the second law. Okay. So these are absorption law. So if you need to draw a logic circuit for this absorption law, what is the first law? What I have is A or AB, A or A and B is same as A. And second law what I have is A and A or B. That is also same as A. Okay. So I will draw the logic circuit here. So A for law 1. For law 1, A and B. A and B. You will get A and B or A. And B or A. Yes. A or A and B. So that is same as A itself. Okay. Similarly, for the load 2, how will you draw? A or B? So A and A or B. A and A or B. A or B and A. Yep, and. Okay, that is A and A or B. That is same as A. So let me try to prove it using the circuit. If A is 0 and B is 1. So what is A and B? A and B is 0. Here A is 0 itself. So what do we get? 0 or 0? That is 0. We get 0. That is this 0 is same as this 0 itself. Okay. Now coming into here, you will get 1 and 0. You will get 1 and 0. You will get 1 or 0. That is 1. Now A and A or B. So you will get 1 and 1. 1 and 1 is 1. So you will get 1. This one is same as this one. That proves the idempotence laws. That proves the idempotence laws. Okay, sorry, not idempotence. That proves the absorption law. That proves the absorption law. Absorption laws. Not the idempotence. Absorption laws. Okay. So now so we have done with 10 laws. I think so. Yeah, right. 9 it is idempotence. Yeah, we will. We have dealt with the redundant literal rule. Okay, we have dealt with the distributive law, redundant literal rule. This is 8th one. Idempotence laws, and 9th one. We have dealt with absorption laws. Okay. So we have dealt with and absorption. After absorption law we have dealt with. Now the last one in this lecture is we will deal with consensus theorem or included factor theorem. That is the 10th one. 10th one is consensus theorem. It is known as consensus theorem or included factor theorem. Consensus theorem or included factor theorem. Okay. So first theorem here is A and B or A bar and C, A bar C or B and C is same as AB or A bar C. That means this factor is included here. Theorem 2. Second theorem, you go for the OR case, that is A or B and A bar or C and B or C is same as only the first two terms, that is A or B and A bar or C. So here what happens is that B or C factor is included in these two terms. So in the first theorem, BC factor is included in these two terms. Okay. So let us try to prove it using some laws which you have done till now. Okay. So for theorem 1, here I am not going with the truth table method. I am going with some other method. So in the first theorem 1, left hand side is A and B or A bar C and BC. Okay. So that I can write it as A and B or A bar and C or BC. Now here what I can see is that here which factor is not there? In BC which factor is not there? A is not there. Okay. So what I can add is A or A bar. What is A or A bar? A or A bar is 1. If you need to add 0, you give A dot A bar. So here I need to add 1. So BC dot 1 is 1. Since here what you can write A or A bar, that is equal to 1 always. That is BC and 1 is always only BC. Now you just expand it. So what will you get? A dot B or A bar C or A and B and C or A bar and B and C. Okay. So here what will you get? Now here what we can take? Here what we can take is that AB is common. AB is common in these two terms. That means AB into 1 or C is AB into 1 or C. Then which is common in these two terms? A bar C is common. Okay. In these two terms, A bar C is common. You can write or A bar C or 1 or B. What is A or 1? C or 1 is 1. Similarly, B or 1 is also 1. So what I can write? That is same as AB and 1 or A bar and C and 1. What is AB dot 1? That is AB itself. So this is also A bar C. Okay. So that is the proof of theorem 1. This is how I am proving with the help of Boolean laws. Okay. So here instead of doing in the truth table, see in these two terms A is there. So here I have added A or A bar. That means A or A bar is always 1. Okay. So that is a key point here. Now let me prove the second theorem. What is the second theorem? That is theorem 2. This is the proof of theorem 1. Now coming to proof of theorem 2. Proof of theorem 2. That is included factor theorem 2. Okay. So what is it? A or B or A bar or C or B or C. And B or C. The A bar or B and A bar or C and B or C is same as A bar or B, and A bar or C. So let me try to prove it. So first of all, what I am going to do is I will expand the left side. Okay, I will expand the left side. And let's just I am expanding it. So what I will do is A bar, this is A bar, or AC, or B A bar, or BC, and B or C. So I have expanded the first two terms. I have expanded the first first two terms. Okay, that is A or A bar. A and A bar. A and A bar is 0. So it is 0 or AC or B A bar, or B A bar, or BC, and B or C. So anything or with 0 is that itself. So you will get it as that is AC or A bar B, AC or A bar B, or BC, and B or C. Okay. Now again I am expanding it. Here we will get A and B and C, and B and C, or C dot C is C itself, and A dot C, or A bar B dot B. A bar B dot B is A bar B itself. Then A bar, this one is A bar BC, A bar BC, or B dot B is B itself. So you will get BC, or then C dot C is C itself. So you will get BC. You get BC. One second, there is a doubt there. One second, let me expand it once more. Okay. AC dot B, that is A dot B dot C, or AC dot C. AC dot C means 0 C is C itself. So that is A dot C, or next one is A bar B dot B. B dot B is B itself. That is A bar B, or A bar B C, okay, or BC dot B. BC dot B, that means you will get B dot B. B dot B is B itself. So answer is BC there, or BC dot C. 0 C is C itself. So here we get BC. Okay. So what will you get? A or A. A or A is A. Similarly, you will get BC or BC. BC or BC is BC itself. So you will get A dot B dot C, or A dot C, or A bar B, or A bar BC, or BC. Now see, BC is common where? Okay. So you can see that BC is common in this term, and this term. Right. So you can write it as BC or BC into A, or A bar BC. Sorry, A bar BC into A bar. You will get only A bar. Okay, BC dot A dot A or A bar or 1. A bar or 1. Or the other two terms, AC or A bar B. Okay. So here what is it is? Here what it comes to? Here what it comes to is anything or 1 is 1 itself. So it is BC or AC or A bar B. It is BC or AC or A bar B. Okay. So let it give it as equation number 1. Now I am expanding the right side. What is our right side? Right side I am getting it as A or B and A bar or C. If I am expanding it, what will I get? A bar or AC or A bar B or BC. What is A bar? It is 0. 0 or AC or A bar B or BC. So answer is you will get AC or A bar B or BC. Okay. Now please check these two answers whether equation 1 and equation 2 is the same. Yeah. So here we get equation 1 is same as equation number 2. Equation 1 is what? BC or AC or A bar B. That is the same as BC or AC or A bar B. That proves theorem number 2. That was theorem number 2. Okay. So that is about the consensus theorem. That is about the consensus theorem or included factor theorem. So included factor theorem means that, or if you are writing a factor here, that factor is already included in the other two terms. That is again in the AND form or OR form. This is the AND form and this is in the OR form. Okay. So with that I am ending with this lecture. Okay. So in this lecture what we have dealt with? In this lecture we have dealt with distributive law, Rodinal literal rule, idempotence law, absorption law, as well as included factor theorem. Okay. So in the next lecture we will be dealing with transposition theorem and De Morgan's laws and Shannon's expansion theorem. Shannon's expansion theorem, there is no proof, but there is proof only for included factor theorem, transposition theorem and De Morgan's laws. So thank you.